This is SpaceTime Series 29, Episode 44, for broadcast on the 13th of April 2026. Coming up on SpaceTime, NASA's Artemis 2 returns safely back to Earth following its historic mission to the Moon. Discovery of the most primitive star ever seen. And there's been yet another fireball spotted, the fifth in as many weeks, this one over the Australian state of Victoria. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Artemis 2 mission has returned safely back to Earth following its historic journey around the Moon. The four-person crew splashed down in the North Pacific Ocean off the San Diego coast, ending their 10-day record-setting flight, which saw them travel further from Earth than humans have ever travelled before.
Splashdown confirmed at 7:07 p.m. Central Time, 5:07 p.m. Pacific Time. From the pages of Jules Verne to a modern-day mission to the Moon, a new chapter of the exploration of our celestial neighbor is complete.
The historic Artemis 2 mission had blasted off from Pad 39B at the Kennedy Space Center in Florida with a 98-metre-tall Space Launch System SLS rocket powering the Orion spacecraft Integrity on the first leg of its 1,118,624-kilometre journey to the Moon and back. The mission has marked the first time the SLS rocket and the Orion spacecraft have carried a human payload. On the way to the Moon, Artemis 2 deployed 4 small CubeSat research satellites. The crew tested the spacecraft systems and manual handling characteristics before getting the green light for the crucial 6-minute TLI or translunar injection burn, which took Orion out of Earth orbit and on a 4-day journey to the Moon.
10 seconds until translunar injection burn start.
Integrity, good engine, good control.
We show the same. Feels great up here.
At MET, mission elapsed time of 1 day, 1 hour, and 14 minutes into the Artemis 2 mission, as Orion was flying 115 statute miles above Earth and 247,600 miles away from the Moon. We have the start of the translunar injection burn that will send the crew around the Moon, the first humans to do so in over 50 years.
Integrity looks like a good burn. We're confirming.
Integrity copies.
Confirmation from teams here on the ground to the Artemis 2 crew aboard Orion. We have translunar injection burn cutoff and early reports that it was a very good burn. Orion now 520 miles away from Earth. Just 5 minutes ago, we were only 115 miles above Earth's surface. That distance will continue to increase as we are now on a trajectory to fly around the Moon for the first time in over 50 years.
The world watched as Integrity sped towards its target, with the public cheering on every milestone along the journey, which was paving the way for future manned missions to the lunar surface. You see, the Artemis 2 mission was very much a manned test run to the Moon and back. It followed the path of the unmanned Artemis 1 mission back in November 2022. And it journeyed a record-setting 406,777.8 kilometres from Earth as Orion swung around the far side of the Moon, 6,400 kilometres above the alien world's grey crater-strewn surface.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny, and thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we get close to the nearest point to the Moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. And so as we prepare to go out of radio communication, we're still to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the Moon.
Houston copies. We'll see you on the other side.
During their voyage around the lunar far side, the crew studied the desolate landscape, identifying many never-before-seen landmarks. One image sent back showed the Moon's Orenthal Basin, a massive crater which had previously only ever been imaged by unmanned spacecraft. And they also suggested names for 2 other craters. The first, named Integrity in honour of their spacecraft, and the second, named Carol, which honours the late wife of Mission Commander Reed Wiseman, who died of cancer. The crater name proposals will now be formally submitted to the International Astronomical Union, the organisation that governs the naming of celestial bodies and their surface features. As well as being the first humans to see the lunar far side in more than half a century, they also witnessed their own private solar eclipse as the moon passed in front of the sun as seen from their vantage point in space. As they travelled around the lunar far side, communications with Mission Control in Houston was lost for around 40 minutes. That loss of signal was expected, as the moon's body blocks the signals between the spacecraft and NASA's Deep Space Network communications dishes back on Earth. In fact, the agency's Tidbinbilla tracking station just south of Canberra was in charge during the lead-up to the loss of signal event and for signal reacquisition as Orion re-emerged from behind the limb of the moon. Canberra DSN spokesperson Rhianna Lyons from the CSIRO says this was the first human mission to the moon since Apollo 17 back in 1972, and all the operators, technicians, engineers and support teams at Tidbinbilla had been preparing for this for years.
So everyone here was pretty cool, calm and collected during the blackout period as they passed around the far side of the moon. We'd prepared for this. It was a planned outage, so we all knew it was coming, and our team had been doing lots of training and preparations to lead up to this moment and what to expect when we lost that signal and we lost those communications as they went around the moon, and then what to expect again when they came back on the other side. And so everyone here was very, very, very cool, calm and collected, very excited, and just sort of a little bit of tension as we waited to make sure everything was all good on the other side. And sure enough, everything went just as we planned and there was no hiccups at all along that way. So everyone here was doing a fantastic job.
How long was the blackout?
It was around 40 minutes.
When we have a blackout during entry to Earth's atmosphere, when the plasma build-up on a spacecraft overwhelms the radio contact, there's a constant chatter going on. Houston Starship or Houston Apollo, as it would have been in the old days. And they just repeat that over and over again until they get a response. Is that the sort of thing that happened?
It could be similar. So I think upon re-entry, it'll be a similar thing to what they would have done during Apollo. But during that 40 minutes, because it's such a long period of time, we knew that we weren't going to be able to contact them until they came back around the other side. So our attention sort of shifted to maintaining communications, making sure that everything was running smoothly so that when they came back around, it was going to be an easy pickup and we were able to get back in contact with them as soon as we were able to.
Which was the primary receiving station for the blackout period?
Because the moon was visible in the sky over Australia, Canberra was the primary receiver during that blackout period. So we were the ones that were tracking and then regaining that communication connection back. But it varies. So throughout the whole mission, the station in Madrid has been doing communications as well as the station in Goldstone, California. So as the moon goes around the Earth and as the Earth rotates, it varies on which station is the one receiving depending on which one is able to get the best view of the mission.
You've got a number of dishes there, including a big 70-metre one. Which dish was doing most of the work, or do they swap depending on what's available at the time?
So there were two antennas that were both doing tracking of Artemis, and they were both doing different communications between the two of them, but ultimately they were doing the overall communications together. We had our 70-metre as one of those antennas, and we also had one of our 34-metre antennas as well.
Looking back at the Apollo days and the Apollo 11 mission, and of course the movie The Dish, which was really big here in Australia, it basically covered how the Parkes Radio Telescope was employed by NASA to help track and provide data for the Apollo 11 moon mission. That's a 64-metre dish. The 70-metre dish you guys were using was even bigger.
Yes. It is even bigger. So our 70-metre antenna, it actually used to be a 64-metre antenna. And then as the Voyager missions got further and further away from the Earth, they actually upgraded our size to be a 70-metre antenna. And now that's the largest antennas that we have across the whole network. But yes, we've got the bigger antenna, the biggest antenna in the Southern Hemisphere, to be exact. So very, very exciting that we're able to support these missions to the moon and also missions that are out beyond, well beyond the moon as well.
How many missions are you tracking at the moment?
There's over 40 active missions active in deep space. So that includes missions at Mars, missions that are looking at the sun, missions doing flybys of other planets, and the Voyager missions, which are now the furthest missions away from the Earth.
And I take it you have to do constant exercises to maintain the ability to track those spacecraft, and also in case something goes wrong, for some reason you lose lock. The spacecraft maneuvers itself in such a way that it loses signal. You have to work to try and regain that signal. There must be a lot of testing you do to do that.
Yeah, so we have around 90 people who work here at our station, and only a small handful of them are the operators. Everyone else are mechanics, engineers, technicians, people who are working on the antennas to make sure that they are in tip-top condition to maintain their tracking abilities so that we're not going to have an antenna breakdown mid-track and then lose a lot of data. So we have lots of regular servicing and maintenance happening on our antennas. So it's a big group effort out here at the station to make sure that everything goes well. And then our trackers are the ones making sure that those signals that we're receiving are the right signals that we want to receive, that there's nothing wrong there. And they're the ones doing all that troubleshooting in case there's anything going on in that radio signal sphere.
I believe there's a lot of camaraderie between not just the Deep Space Network of NASA, but also the European Space Agency's own network.
Yeah, so we do a little bit with the other networks that might be out there, but our predominant role is with the other stations in the Deep Space Network. So we work very closely with Madrid, we work very closely with Goldstone, California, and we also work very closely with the Jet Propulsion Lab over in the United States, a part of NASA. So we work quite collaboratively amongst those 3 points, and then sometimes we might get a little bit of stuff with other stations around the world as well, depending on what is needed to be done.
For the Artemis mission, what special things have you been doing?
We've been doing those primary communications. So we've sort of gone back to a similar role that we would have had during Apollo, making sure that the primary communications with the mission are all going well, going smoothly. We're able to contact them, they're able to contact us, and we're receiving back everything that we need to receive from that. So we're doing a constant role in the background. During the daytime here in Australia, our operators are the ones managing the whole network. So they're not just using the antennas here in Canberra, they're also using the ones in Madrid and California. So we've been making sure that whilst the sun is in the sky over here and the moon is in the sky in Australia, we've been able to maintain those communications and ensure that the other stations have been able to do the same.
Now, one of the great controversies about the Apollo mission was that it wasn't your fault, but the audio, the vision was lost for quite some time. That can't happen these days. There's backups for backups for backups, aren't there?
Yes, there is. They've got lots of contingencies and redundancies in place to make sure that if something doesn't work, they've got something else to do it as well. And so that's why we've got the Deep Space Network here. We've got lots of other places. It's a very global collaborative effort. Just as Apollo was, it's the same for Artemis, but even on a larger scale now. So we've got lots and lots of things in place to make sure that we're able to keep tracking and receiving everything that we need from this mission.
Now, under the current Trump plan, we're going to have an Artemis launch at least once a year, so that's an incredible increase in cadence. And of course, as well as that, there's going to be lots of activity on the lunar surface as well. That'll be transmitting data here and there and everywhere. That's going to make things very busy, isn't it?
It is going to make things very busy, but it's going to make things very exciting as well. So we know that Artemis 3, it's just changed from a lunar landing to orbit around Earth to ensure that all of their systems are working, do more maneuvers and more testing of the module. But then Artemis 4 is going to be the big one to cast your eyes to, because that's when we're going to be landing back on the lunar surface, which is going to be such an incredible moment. As amazing as Artemis 2 is, and as historic as it is, there's only more. You know, the sky, the moon is the limit, right? It's even further than that now. So Artemis 2 has really set the pavement for future Artemis missions to go and continue the exploration that we've started back with Apollo.
Do you still monitor Voyager 2?
We do. We are always in contact with Voyager 2 very frequently. We're the only tracking station in the world that is able to send a signal to Voyager 2 and receive a signal. So we spend a lot of time with that mission as it continues traveling away from our solar system.
Okay, here's the tough one for you. Can you still contact the original Pioneer 10 and 11 probes?
No, we can't. I know.
They were used for training exercises for a while there. Once they were decommissioned, they were still used as training exercises for your guys to see if they can find them and contact them.
Yeah, so back when we could still contact them, we did contact them frequently, even though they weren't doing any science at that time. But no, we're not in contact with them anymore. The furthest missions away that we contacted the Voyager ones, and so we spend a lot of our time tracking those missions, as well as the 40 other missions that are in our solar system as well.
That's DSN spokesperson Rhianna Lyons from the CSIRO. During their lunar flyby, a fleet of cameras were used to capture imagery of the moon, including features humans had never directly seen before. They also saw several flashes of light as meteors slammed into the lunar surface before their very eyes. The crew used a variety of digital handheld cameras to conduct high-resolution photography of the lunar surface. See, the Artemis 2 mission is providing NASA with an opportunity to gather as much data as possible on the topography and geological features of the lunar far side under varying illumination conditions, thereby allowing shadows to add never-before-seen depth and texture to this alien landscape. The photos, videos, mission telemetry, and communications information will all be used to help determine landing sites for future Artemis missions, as NASA embarks on the development of its lunar base near the Moon's south pole. After being flung around the Moon in a gravity assist maneuver, Integrity was on course to return to Earth using a free return trajectory. As it approached our home planet, crew began reconfiguring Orion for atmospheric re-entry. The European service module was jettisoned, and the capsule began the most dangerous part of the entire mission.
10 seconds till entry interface, and we have crossed the threshold, now entering the Earth's atmosphere. We're at 400,000 feet, traveling 34,800 feet per second. Time to splash down, 13 minutes, 10 seconds. And as predicted, we've entered our communications blackout. This will be a 6-minute blackout period. No voice, no data from the crew.
Orion was maneuvered so the heat shield faces forward. They re-entered Earth's atmosphere at over 38,000 kilometres an hour. Now that's fast enough to travel from Sydney to Perth or New York to LA in just 5 minutes.
We're 30 seconds away from the anticipated point of peak heating on the vehicle, where temperatures will rise to about 4,000 to 5,000 degrees Fahrenheit. This is the true test of our trajectory. The vehicle, as it enters the period of peak heating in the Earth's atmosphere, the first tug of gravity being felt by Integrity's astronauts since their launch back on April 1st.
Temperatures reached over 2,700 degrees Celsius, half as hot as the surface of the sun. And for all this, their only protection was the spacecraft's 5-metre heat shield, an improved version of the one which broke apart during the previous Artemis 1 mission.
4.5 minutes until the end of the blackout period. Time to splash down, 11 minutes, 33 seconds. The landing and support officer reports that the P-3 has acquisition on Integrity. 3.5 minutes left in this blackout period. The plasma buildup around the spacecraft and the repelling of that heat on Integrity's heat shield. Flight Dynamics reports that airborne assets in the vicinity of the splashdown zone do have a visual on Integrity. Still 2 minutes and 40 seconds left in our blackout period. Time to splashdown, 9 minutes, 35 seconds. Multiple airborne assets as part of the recovery team all have visuals on Integrity. And the WB-57 flying in the splashdown zone also has a visual. And the Navy helos also have visuals. We're still in the blackout period, still do not have communications from the crew. We should be out of the blackout period less than a minute from now. We are now processing data from Integrity. Landing and support officer reports the small boats are en route to the splashdown target zone. Passing through 150,000 feet, our trajectory is perfect. Still waiting to establish voice communication.
Integrity, Houston, comm check, post-blackout.
Houston, Integrity, we have you loud and clear.
Your trajectory is nominal, and your recovery teams have visual.
Guidance looks good.
No action for the enabled internal camera controller fail.
Big cheers from the viewing room here in Mission Control as voice communication reestablished with Commander Reed Wiseman. For America and a waiting world, Integrity is 5.5 minutes away from coming home. Passing 100,000 feet now, range to splashdown 19 nautical miles.
Integrity, impact to the camera controller fail is no Cab 1 views of the chute.
Integrity.
We're processing good data through the GPS system. We're at 50,000 feet. The pyros are armed for forward bay cover jettisons.
As the spacecraft plunged through its atmosphere, 7 drogue and main parachutes were deployed to slow Integrity down.
And there go the first series of parachutes, and we're on drogues.
And Houston, we're visual 2 drogues out the window.
2 good drogue chutes.
We copy, we see them.
Next up, the deployment of pilot parachutes that will pull the main chutes out. Time to splash down 3 minutes and 10 seconds. Perfect descent rate according to Flight Dynamics.
Good rates on 2 drogues.
We see the same on board.
Passing through 10,000 feet, still on drogues. Main chute deploy. We're at 5,000 feet. Search and recovery beacon has been activated on Integrity. And we have 3 good main chutes. Good reefing, good descent rate.
Good rates, and we see 3 good-looking parachutes. Integrity, cabin pressure indicates no need for hydrazine check.
Integrity copies.
This is a perfect descent for Integrity. Its crew sounding hale and hearty on board. Time to splash down 1 minute, 15 seconds. Integrity about to complete a journey spanning 694,481 miles from its launch from the Kennedy Space Center back on April 1st, and a trip around the moon, passing through 1,000 feet.
Houston Integrity, splashdown, sending post-landing command now.
Splashdown confirmed.
Copy splashdown, waiting on VLDR.
A perfect bullseye splashdown for Integrity and its 4 astronauts. Integrity's astronauts back on Earth. And the landing and support officer reports the vehicle is stable 1. We still will be deploying the crew module uprighting system to maintain that orientation. The unofficial splashdown time, 7:07 and 47 seconds p.m. Central Time. That would put the end of the mission at a mission elapsed time of 9 days, 1 hour, 31 minutes, 35 seconds.
Following splashdown, recovery teams retrieved the crew using helicopters, delivering them to the US Navy's USS John P. Murtha. Once on board, the astronauts underwent post-flight medical evaluations in the ship's sickbay before being flown back to shore to meet with an aircraft bound for NASA's Johnson Space Flight Center in Houston, Texas. One issue, which NASA will definitely need to address, is the Orion spacecraft's disastrous dunny. The Lunar Loo initially began to malfunction shortly after launch, and it's been a, dare I say, hit-and-miss affair, for want of a better term, ever since. Extraterrestrial toilets on space shuttles and on the International Space Station have also had their problems, but they mostly worked well. A version of the Orion weightless water closet was tested in microgravity conditions aboard the space station before being approved for use on Artemis 2. But the cosmic commode as installed on Orion wasn't a flushing success, forcing Mission Control to request crew members use backup urine collection bags instead, at least for number ones. Engineers suspect that ice may have been blocking the line, preventing urine from completely flushing overboard. The good news is the toilet was still open for number twos, thereby relieving the crew of the need to wear diapers. And the problems didn't end there. The astronauts also reported a smell coming from the celestial throne, which is buried in the floor of the capsule behind a door and privacy curtain. But all that aside, Artemis 2 marks the start of America's return to the moon, this time to stay, and with plans to land near the lunar South Pole in 2028 on the Artemis 4 mission and begin the long process of setting up a permanent base there by 2030. Orion only takes astronauts from Earth to lunar orbit. Getting from lunar orbit down to the surface and back again will be the responsibility of a different type of spacecraft, a lunar lander, two of which, SpaceX's giant Starship HLS and Blue Origin's more moderately sized integrated lander vehicle, are now being developed for the mission. The next Artemis flight, Artemis 3, which is slated for next year, will test both lander designs in low Earth orbit, checking out their flight characteristics and practicing docking maneuvers with the Orion spacecraft. Each lander will also need to undertake a successful unmanned landing on the lunar surface and then return to lunar orbit. Potential landing sites around the lunar South Pole are still being investigated, with 9 currently on the shortlist. Once a permanent lunar base is established and operational, the moon will then become a jumping-off point for future manned missions to Mars and beyond. This is SpaceTime. Still to come, astronomers discover the most primitive star ever seen, and there's been yet another fireball spotted, the 5th in as many weeks, this one over the Australian state of Victoria. All that and more still to come on SpaceTime. Astronomers have identified one of the most primitive stars ever seen, and the nearest candidate yet found to the first generation of stars created out of the primordial material of the Big Bang. The new research, reported in the journal Nature Astronomy, could lead to new insights about the formation of the universe's first stars. The newly discovered star, catalogued as SDSS J0715-7334, was located some 80,000 light-years away in the vicinity of the Large Magellanic Cloud, a small satellite dwarf galaxy which orbits our own Milky Way galaxy. Astronomers are describing it as a prime example of a population 2 star. Population 2s are a group of stars made directly out of the material created by the very first generation of stars in the universe, which are known as population 3 stars, and which themselves were formed directly out of the pristine hydrogen and helium created in the Big Bang. See, in the first moments of the universe after the Big Bang 13.8 billion years ago, the cosmos consisted of an ionized soup of quark-gluon plasma. Eventually, after around 380,000 years, this plasma had cooled enough for the first atoms of hydrogen and helium to form. Now, some patches were denser than others, and after a few 100 million years, their gravity overcame the universe's outward expansion trajectory, and the denser clouds of this material began to collapse inwards on themselves, eventually forming the first generation of stars, the population 3 stars we mentioned earlier. Now, astronomers have never actually seen a population 3 star. That's because of their unusual composition. They're thought to have all been extremely massive and luminous giant blue stars. And the thing is, high-mass stars like these burn through their nuclear fuel supplies much quicker than low-mass stars like our Sun. They're often described as being the James Deans of the stellar world, living fast and dying young, often surviving for just a few million years before going supernova. By comparison, a yellow dwarf star like our Sun will live for around 12 billion years, and even less massive red dwarf stars could theoretically live for trillions of years. The thing about stars is they create heavier elements either through the fusion of lighter elements in their core during their lifetimes or through more violent fusion processes as they explode as supernovae or they merge, releasing incredible gravitational forces. Although they were initially formed out of nothing but hydrogen and helium, with maybe a little bit of lithium and beryllium there as well, population 3 stars evolved to produce all the other elements in the universe, including the iron in your blood, phosphorus in your bones, and the calcium in your teeth. And when these population 3 stars explode, they spread all those elements throughout the universe, eventually to be recycled into the first population 2 stars. Population 2 stars, like SDSS J0715-7334, can be identified by their composition. They have what's known as low metallicity, meaning they're metal poor because they only contain small amounts of heavier elements. That's because there were so few heavy elements available in the ancient universe. Now, by the way, astronomers refer to all elements other than hydrogen and helium as metals. Over time, as more and more stars were born and ultimately died, greater and greater amounts of heavier elements became available to seed the universe, eventually leading to the creation of more and more high metallicity stars, including the metal-rich population 1 stars like our Sun. So, by studying a star's metallicity through its composition, astronomers can determine the age of the star, at least in terms of its evolutionary position in the universe. SDSS J0715-7334 is still composed primarily of hydrogen and helium, and it contains less than 0.005% of the metals we find in the Sun. One of the study's authors, Kevin Schlaufman from Johns Hopkins University, says the properties of the first stellar generation are some of the most important unknowns in modern astrophysics. It was Schlaufman who originally identified SDSS J0715-7334 as a star of interest back in 2014 as part of the current 5th generation of the Sloan Digital All-Sky Survey. He says, while this star doesn't have a primordial composition itself, it's the closest astronomers have ever gotten to population 3 stars. SDSS J0715-7334 was formed directly out of the cloud of gas that had interacted with material ejected by a population 3 star supernova. Working backwards, Schlaufman and colleagues can use the ratios of the elements in this star to explore the mass of that earlier population 3 star and the energy of its supernova explosion. The authors have analysed data gathered with the Magellan Clay Telescope and its high-resolution spectrograph to determine that SDSS J0715-7334 is almost entirely hydrogen and helium, with only trace amounts of carbon and iron. They say the composition of the star indicates that the earlier progenitor population 3 star that produced its carbon and iron was both unusually massive and exploded with uncommon vigour. Schlaufman says SDSS J0715-7334's long history of living alone has allowed it to ingest material from the cosmic web for longer periods than stars in the Milky Way. Those conditions may have promoted the production of other low metallicity stars. Schlaufman thinks it's possible that astronomers will ultimately find a relatively higher proportion of ultra-low metal-poor stars in galaxies like the Magellanic Clouds compared to the stars we see in our own Milky Way galaxy. This is SpaceTime. Still to come, yet another fireball spotted, the 5th in 5 weeks, this one over the Australian state of Victoria. And later in the science report, a new study has shown that summer is arriving earlier, lasting longer, and packing more heat than ever before. All that and more still to come on SpaceTime. Residents in the town of Rutherglen, in the Australian state of Victoria, have reported a large green fireball streaking across the sky. It's the latest in a spate of high-visibility meteor sightings over the past month or so, with others reported in Germany, Ohio, Texas, and Washington state. NASA says it's all part of what astronomers call fireball season, an annual increase in meteor sightings between February and April. In fact, the rate of these very bright meteors can increase by as much as 30%, especially in the weeks around the March equinox, which usually falls on March the 20th or 21st. Because different elements inside a meteor will burn at different temperatures, the colour of the meteor as it streaks through the atmosphere can help astronomers identify its composition and the atmospheric gases that ionize during its entry. The common colours include yellow, which indicates lots of iron, orange, which suggests the presence of sodium, blue and green meteors usually contain lots of magnesium, violet suggests calcium, and red means atmospheric nitrogen and oxygen. And the more intense the colour suggests the faster the meteor is travelling. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has shown that summer weather is arriving earlier, lasting longer, and packing more heat than it used to. And it's all happening much faster than scientists had previously measured. The findings, reported in the journal Environmental Research Letters, shows that between 1990 and 2023, the average summer between the tropics and the polar circles grew about 6 days longer per decade. And that's up from the roughly 4 days per decade found in past research investigating the years leading up to the early 2010s. For many cities, the numbers are even more striking. Sydney, for example, has summer temperatures now lasting around 130 days, up from the 80 days back in 1990, which means an extra 15 days per decade. And even in colder climes like Toronto, summers are expanding by about 8 days per decade. Now, the authors didn't use the calendar definition of summer, that's June through to August in the Northern Hemisphere and December through February in the Southern Hemisphere. Instead, they define summer based on the weather, the stretch of days in each year when temperatures rise above what was historically typical for a given location during the warmest part of the year. A threshold set using climate data gathered between 1961 and 1990. Now, these findings have widespread implications for agriculture, water supply, public health, and energy systems, many of which have been built around assumptions about when the warm season begins and when it ends. A new study confirms that people living with obstructive sleep apnea have a 71% higher risk of heart issues or death. The findings have been presented at this year's European Congress on Obesity in Istanbul. The study compared 20,300 people diagnosed with sleep apnea to some 97,000 people without the condition. Along with heightened heart and death risk, the group with sleep apnea were also more likely to develop obesity, diabetes, osteoarthritis, anxiety, and depression. The authors say the findings highlight the need for early screening and diagnosis of the condition. The Australian Navy is investing in a new fleet of 40 locally designed and built Blue Bottle unmanned surface vessels. The new drones, which are being built in Sydney, will increase the Navy's operational fleet of Blue Bottles to 55. These vessels are used for long-range intelligence, surveillance and reconnaissance operations, silently monitoring Australia's maritime approaches. News of the new contract follows a recent deal by the Navy to purchase dozens of Ghost Shark autonomous underwater vehicles. That fleet will work in conjunction with manned submarines and surface vessels, providing long-range stealth capabilities for underwater reconnaissance, intelligence gathering, strike missions, and mine-clearing operations. There's growing evidence that many teachers are taking up the profession not to educate children and teach them how to think, but to indoctrinate them in what to think. That's why public school attendances are dropping while private and homeschooling is increasing in popularity. But it seems not all private schools are doing the right thing by children in their care, as the Skeptic's Tim Mendham explains.
Queensland has always been a bit of a hotbed of creationism, which is the fundamentalist view that the Bible is literally correct. Earth is 6,000 years old, and that Noah's Ark existed and the animals were put on there, including baby dinosaurs. Keep them going. So the Skeptics have had a bit of a history of this. One of the earliest sort of projects the Skeptics did in Australia was to put out a book called Creationism. It would go through all the arguments that were being put forward at the time by scientific, in quotes, creationists, and analysed them and assessed them and found them wanting. And this was because creationism was being taught in science classes, in state schools. It was successful. It certainly disappeared from the science classes and things, and it's always been a bit of a fringe area. Unlike in America, where creationism is quite large and active, in Australia it's not, because we're not a particularly religious nation as well, for a start, but also because people just don't regard this fundamentalism as scientifically valid. Anyway, the creationist movement split, one lot staying in Australia, one lot going up largely to America. A lot of the leading American creationists are Australians, one of our more successful exports, but it's now coming back a bit. Now, in a religious school, and there are private schools here in Australia run by religious organisations, and this one is run by the Open Brethren organisation through the Christian Community Ministries. I think they have about 15 schools around Australia, not just in Queensland, and they have had a lot of interest in Noah's Ark and dinosaurs, etc. I think they probably visited the one in the US, started by an Australian, a huge model of Noah's Ark, including dinosaurs in the little stalls eating vegetarian dinosaurs, obviously. They don't want dinosaurs rampaging through the ark. And now they've said that this should be taught in science classes. Obviously, this has led to a lot of controversy. There is a curriculum which is established by state governments, education departments, saying this is what you have to teach, and evolution is one of the things that you have to teach rather than a divine creation idea. And they're obliged to teach it, even these private schools. But what they're throwing in is this extra bit, which some people justify by saying it's good to have both sides of the story. Well, of course, teaching evolution as we understand it, scientific evolution, and creationist views of fundamental creation of the world is not just two sides of the story. There are a lot of other creation stories out there, but they don't cover those. They don't cover First Nations creation stories or other religious Buddhist Hindu creation stories. They only cover this Christian Noah's Ark literal truth story, and then they begrudgingly also teach evolution. So it's not giving people a balanced view by any means. For a start, the science behind creationism is poor, just to be generous to it, and that there are other creation stories as well, which they, if they were honest about it or legit about it, they would be covering those as well.
See, I don't mind kids being taught about creationism, but you teach it in a specific religious class. You don't teach it in a science class. Science class should be for science only.
That's always been the skeptic's point of view. Teach it in a comparative religion class. That's fine. You can compare with other religions, but it's not science. So it should not have that imprimatur of being taught in a science class. What the fear is that is it's being allowed to get in by a distrust of science, which is being fed through a lot of different avenues about that have cropped up, anti-vax, anti-climate change, and in this case anti-evolutionists, and a general view that scientists don't know what they're talking about, but the Bible does. Therefore, it's a symptom of a couple of things. One is the religious fundamentalism, which is not strong in Australia. Even in Catholic schools and things, they don't teach it in Catholic schools.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.